Hello, algebra classes. We're going to take a look at our 9.6a samples, where we're going to solve each equation by using the quadratic formula. That will be our method of choice. So even if you see an easier way, such as factoring or taking the square root, you're still going to use the quadratic formula to solve. We'll round each answer to the nearest hundredth. Okay, so our first equation, x squared plus 3x minus 9 equals 0. Well, we already have that equation in standard form. We are in order from the highest exponent on the variable to the lowest, and we're equal to 0. That's what makes it standard form. So pulling off our a, b, and c, the coefficient on the x squared is 1, coefficient on the x term is 3, and the constant is negative 9. Okay, now we're going to think about that quadratic formula. I've written it in a thinking bubble when I was working with you on your guided practice problems yesterday, and in your homework I'm hoping you were writing that down each time, but we really don't need to from now on because it's in our head now when we sing x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we're going to use that as the template to fill in our a, b, and c to that quadratic formula so we can solve for x. So x equals the opposite of b. The opposite of b is negative 3 plus or minus the square root of b squared. B squared is 3 squared minus 4a. A is 1. C is negative 9 all over 2a. A is 1. Okay, now we're going to simplify. Towards the end of the problem, we'll start using our calculator, but for now, it's just simplifying what we have. We're going to work in the radical first. Everything else will stay the same. 3 squared is 9. And we are subtracting a negative number. 4 times 1 times negative 9 is negative 36 because we have two positives and one negative. So 4 times 1, 4 times negative 9, negative 36. But we're subtracting a negative, so that becomes plus. A fast way to figure out what's happening in between that 3 squared and the rest of it is to count the number of negative signs or minus signs. Put them all together, minus a negative. 2 minus or negative signs, and a negative times a negative makes a positive whenever we multiply, so that's why we're adding. Okay, our next step is to add that 9 plus 36, so we can get 45. And we are going to, at this point, look on our calculator and work out what the square root of 45 is to the nearest hundredth. We are reducing our accuracy slightly by only reporting to the nearest hundredth here, but for what we're doing, that's okay for right now. All right, so we have negative 3 plus or minus 6.71 approximately for a square root of 45 over 2. And then we're going to rewrite this expression into the two different computations we need to carry out. Negative 3 plus 6.71 over 2, that's what we have here. Negative 3 minus 6.71 over 2, and that's what we have here. We use our calculator to help us work out each of these. And rounded to the nearest hundredth, we'll have 1.86 and negative 4.86. So we're always going to be rounding to the nearest hundredth on these. All right, our last sample problem, sample 2, will be the same kind of problem. It'll be a quadratic equation that's already in standard form for us because it's equal to 0. And we have from our highest exponent on the variable down to our constant. So we're immediately going to pull off our a, our b, and our c. A is negative 5, b is negative 9, and c is negative 3. And here we've written that quadratic formula in a thinking bubble. That, again, can be dropped off at this point because you've written it enough times, and it should start to be sticking in your brain. And now we're going to plug into this formula. X equals the opposite of b. B is negative 9, so the opposite is 9, plus or minus the square root of b squared. B squared is negative 9 squared. Minus 4, a is negative 5, c is negative 3, all over 2, a is negative 5. Okay, so now we're ready to start simplifying. Now I've drawn a little thinking bubble around my minus 4 times negative 5 times negative 3. And I've written over here what I'm doing to think that through. So I'm subtracting 4 times negative 5, which is negative 20, times negative 3, which is positive 60. So I'm subtracting a positive 60. These two negatives cancel each other out, so I'm subtracting a 60. I count 1, 2, 3 negative or minus signs. Whenever I have an odd number of negative and minus signs, that's going to mean that I'm going to end up subtracting. So 81 for my negative 9 squared minus 60. Notice that negative 9 is in parentheses because I am squaring negative 9, which happens to turn out to be positive, but the parentheses have to be there to show that I'm squaring negative 9 and not just 9. All right, so we have 9 plus or minus the square root of 81 minus 60 over negative 10. Simplifying in the radical, 81 minus 60 is 21. And again, this is the point where we're going to start to use our calculator. We will reduce our accuracy slightly here because we are running to the nearest hundredth. And for what we're doing, we're going to say that's okay. We could leave this all in our calculator at this point, but we're going to go ahead and rewrite that as its approximation to the nearest hundredth. So we have 9 plus or minus 4.58 for our square root of 21 over negative 10. Pull this calculation apart into the two different computations you need to carry out to work out the values of x. And here I am adding, and here I am subtracting the 9 plus and minus that 4.58. And so we're going to work each of these out on our calculator. Because I've already done some rounding up here on my calculator, I'm only going to see 3 digits, and then I'm going to round that to the nearest hundredth at that point. So this 8 will round the 5 up to 6, and this 2 will round the 4 to 4. So there's my two final values for x to solve this quadratic equation. All right, let's make sure that this set of samples is in your notes, review them, and then when you're ready, move on to the quiz for 9.6a, and we'll see you the next time.